Good afternoon, everyone. Thank you for joining today's webinar, Network Architecture Options for Azure and Multi-Cloud Deployments. We've got a great hour of content here. I think everyone's going to be real happy with what the takeaways are. Before we jump into the introduction for our panelists, I'd like to personally thank Computex Technology Solutions for sponsoring today's webinar. And with that, let's go ahead and jump into the introductions. So the first speaker I'd like to introduce is Brian Ashley. He is a Principal Solutions Architect at Aviatrix. And Brian's background is pretty interesting. He was one of 8 black belts for Azure, specifically focused on the network. And those 8 architects covered North America, South America. Brian has been with Aviatrix now for about 6 months and is really a domain expert on some of the challenges and also some of the options for Azure and multi-cloud deployments. Our other speaker is Faisal Khan, who was a senior systems engineer here at Aviatrix. And Faisal's been here for a little over 9 months as well. And we've got a great story here this afternoon. Again, I'm John Beavis, Aviatrix Senior Client Executive. And we are privileged and happy that everyone was able to join. We've got a great audience and people are continuing to come in. So with that, why don't we go ahead and go through the agenda and move to the next slide. But specifically what we'll cover is a little bit about Aviatrix and then the problems that Aviatrix is trying to solve or attempting to solve and solving for our 500 plus customers in the market today. As well as then we'll move to more of a Aviatrix multi-cloud network architecture. So we'll cover that specifically and how the platform provides essentially one architecture, one network, any cloud. And then we'll move into Azure specific design challenges and how Aviatrix addresses them. And then finally, we'll show the latest version of Copilot. There's nothing else in the industry like this today. And Faisal will be walking through that demonstration. So with that, I will go ahead and hand it over to Faisal and we can start the content. Faisal?
Thank you, John. Appreciate it. So excited to be here and I hope you'll find this content useful. So, whether you are sort of just starting off your cloud journey or you already are in one cloud or many cloud, this discussion will be relevant. We actually decided that we will use Azure as a framework to explain you the issues that are in the cloud and what solution Aviatrix have. Azure is, of course, predominantly getting a lot of speed and traction. So I'm expecting, since you are joining us today, you have some Azure presence or you're at least looking at Azure. So please make this as interactive as possible. We don't have audio for you, but what you can do is submit your questions on the chat window here and me and Brian will answer that. And actually what we can do is if you need some deeper dive, we can always tackle that offline. But at the end of this webinar, we'll actually address those questions as well, just in case if you need a lot more explanation. So with that, let me kind of just give you a quick overview on who Aviatrix is in case you have not been exposed to us. So Aviatrix is an enterprise-grade cloud networking and security software platform for single cloud or multi-cloud customers. We are actually, 7-8 years old company. We are in the 6th iteration of our software platform, so pretty mature solution. We basically abstract the complexity of public clouds, providing you management, operations, visibility, and orchestration. We actually, utilize the cloud native capabilities. We embrace them and then we extend them when it's needed for your enhanced capability, for more performance, for more features. That's where you look at Aviatrix. The Aviatrix solution is also all about architecture. We have a framework, a repeatable architecture that's common. You can sort of deploy this common across any CSP, and you have an operational model to follow in the cloud, an architecture to follow in the cloud. So we are way passing now over 500 customers in all different types of vertical, from technology to retail, transportation, financial industry. This solution is for anybody and everybody who is looking at cloud and want to do enterprise class networking and security in the cloud. So these are some referenceable customers. Happy to get you information offline for any specific use case or any specific vertical. So happy to engage in that conversation as well. Aviatrix partners with a few different entities here. So if you look at from the perspective of operations and orchestration, we actually are Terraform provider. We have a partnership with Ansible. We actually work with a lot of IDP systems, Okta, Duo in that case, to give you authentication and authorization solutions. We work with a lot of vendors that are in the logging and in that space. So Splunk, Datadog, Sumo Logic, all of those integrations are embedded onto our controller. We of course exist because of the CSPs. So 4 major CSP providers: Azure, AWS, GCP, and Oracle. We have solution in all of them, and we are looking at other ones. On the security front, we partner heavily with Checkpoint, Palo Alto, and Fortinet, the 3 major next generation firewall vendors. This integration is pretty solid. It comes in almost all of the use cases. How do I insert firewalls into the overall security of my cloud? So we partner with them. So the first big question is, what is the problem that Aviatrix is trying to solve? That should be sort of addressed upfront here. If you look at these individual CSPs, these 4 major CSPs that are out there, we know that they work very differently from each other. There's complexity that's involved in each of these. AWS does things very differently than Azure at a very high level. Yes, it's cloud networking, but it's done very differently. So you have this skill gap that you find as you look at your workforce. Some people are good in Azure, others have no clue about AWS. GCP is a completely different animal. So what you see is that there's a skill gap in terms of doing things in each of these CSPs, and you as a customer are seeing more and more demand from your business, from your workloads, to be able to diversify yourself. And so this complexity and skill gap is something that you have to address upfront. There's no going away from it. The other thing is that the solution that these CSPs are providing you, it's not enterprise at all. If you go and ask AWS or Azure, they'll tell you they have everything you ever need, and you don't need to go to a second cloud or third cloud. But the reality is very, very different. When you start to deal with multiple clouds, the complexity increases, and what you come to find is that these solutions, these networking and security solutions that are there, they just lack capability. They are either lacking in terms of performance, they are lacking in terms of scale, they are lacking in terms of features, right? So things like high availability isn't there, encryption isn't there, there's almost no visibility. And so you need a lot of automation to be able to get to the speed that your DevOps teams are expecting. So while you do move into the cloud, what you realize is that networking is so hard in these clouds, and troubleshooting is so hard that you end up being slow anyway. So what's the point? We need the type of agility that the cloud provides, but of course, because it's so hard, you end up looking at what to do, right? So this is where Aviatrix comes in. Our solution actually touch a lot of different areas. So if you look at within the cloud, we've got the cloud application layer, we've got the cloud core networking layer, and we have the cloud access layer. Aviatrix just touches on all of these aspects of the cloud networking. Our solution, of course, provide you a lot of networking services, the security services. We look at the operational aspect of the solution, and then we basically partner with a lot of different things that you would have to incorporate into your cloud design. So some examples of networking services would be, let's say, transit, advanced transit. You need the capability to be able to build a enterprise class core routed network, right? So this is what Aviatrix provides. You have problems like multiple account problems. How do you ingest all of those accounts across your company? How do you deal with multi-region, multi-cloud connectivity? How do you do this all with performance and scale? How do you do high availability? And then on the security side, how do you insert firewalls? How do you build an ingress and egress architecture? How do you ingest your VPN connections? Maybe you have branches that are coming in. Your VPN users are coming in. And then how do you do it not only encrypted, but also do it at high performance? Then visibility becomes very key. Where are all the flows? Who are the top talkers? How do I troubleshoot a given flow? And how do I do this not just in one cloud, but across cloud, right? And then being able to automate and orchestrate with, say, like Terraform, to be able to really deploy things very, very fast or turn them down very, very fast, right? And then, of course, in terms of your partners, like let's say if you're deploying a network, how do you integrate services into your flow? So how do you insert a firewall as an example? How do you then insert your SD-WAN network into the cloud? Everybody's consuming the cloud. Data center is consuming the cloud. Branch is consuming the cloud. So Aviatrix really sort of gives you a solution and architecture that will bind all of these things and give you a holistic enterprise class solution. So last slide is about overall how our platform is. So we are a controller based solution. So you have got Aviatrix controller in your favorite cloud. So in this case, if we are talking about Azure, you deploy the controller in Azure in one of the region, and then you basically build a data plane with Aviatrix. So these gateways sit in different VNets across your single region or multiple regions. And then the controller essentially builds this environment with these Aviatrix gateways. And actually it incorporates all of those native constructs as well. So things like, doing route table programming into your VNets. We do that as well. The controller actually talks to the firewall vendors, next generation firewall vendors, to insert those firewalls into the traffic flow. And along with all of this, we have an entity called Copilot, which gives you multi-cloud operational visibility. It gives you flow IQ, intelligence in terms of different flows, where they are going, who are they talking to, and then gives you a topology view of everything. So I let Brian have you explain the overall architecture as it plays out in the multi-cloud, and then we'll focus actually on Azure. So I'm going to stop sharing here and let Brian share on his end.
Thanks, Faisal. Okay, so as Faisal mentioned, we sort of walked through the different components of the solution. So what we want to do now is start to stitch those together, see how the various use cases that the Aviatrix platform brings starts to bring value to customers that are in the cloud, whether they're in multiple clouds, single cloud today, as well as dive into some very specific use cases within Azure. So if we take the components that Faisal first was just mentioning in the previous slide, again, it all starts with this Aviatrix controller, right? You just need to launch one controller. Doesn't matter if you're in multiple clouds or single clouds. You only deploy that once. And then that controller is really the brains of the operation. He has the ability to be multilingual. He can talk to multiple clouds. He can talk to those third-party devices that Faisal mentioned and start to stitch things together, as well as talk to the native Aviatrix gateways to start to add on advanced services. So as organizations start typically in a single region, they may be single account or multi-account, or in Azure speak, single subscription or multi-subscription. But there tends to be some base needs for high availability and performance and things like that. Then as things start to scale out, which is inevitable for most organizations, we scale into another region. The nice thing about the Aviatrix platform is that, as you can see, we build on a hub and spoke type topology, but it's workflow based within our controller. So whether, and we'll talk a little bit about infrastructure as code as well towards the end of this webinar, but regardless of whether you're an IAC shop or you're GUI driven, it's a very follow your nose workflow to deploy hub and spoke or transit connectivity. And then in addition to that, with the Aviatrix gateways, we encrypt by default. So the red lines that you see here between all of our gateways are all encrypted. Now, as an organization, whether they have an internal need to expand to multiple clouds, or their customers or partners or users who are consuming their applications exist in other clouds, that it's that same workflow. We follow the same steps to repeat this design across multiple clouds. And so what that really gives you is what we refer to as cloud optionality. So it doesn't matter, we abstract the complexity and uniqueness of each cloud under the hood. And the AVHX platform takes care of automating and orchestrating all of the bits and pieces to tie all this together. So for you as a user, all you have to worry about is how do I make things work and how do I define my intent in the AVHX controller, and then the AVHX platform works out all the stitching underneath to connect all of these bits and pieces. So what that results in is a reduction in the knowledge gap when it comes to cloud networking in general, but also the nuances between clouds. We abstract all of that away from you as the customer and go ahead and take care of that all on the back end. Then through our gateways, we start to layer in some of the advanced services that Faisal was mentioning. So one of the big ones, as I mentioned, we do provide encryption by default between our gateways. However, if you've ever tried to do encryption in the cloud, you probably have run into a limitation of about 1.25 gig. That's not cloud specific. That's across all providers, and it's really just the way that IPsec is handled from a kernel perspective in the cloud. So one of the things that AVHX did when we first started was we basically said, okay, we're going to scrap that and we're going to rebuild the kernel ourselves within our gateways. And what that allowed us is the ability to get near line rate encryption both within the cloud. So whether we're talking VNet to VNet, within a region, cross region, we can even do that cross cloud. Now there may be some limitations there depending upon ingress and egress limitations. But another big use case is to on-prem. So if we look at the private circuits like AWS Direct Connect or Azure Express Routes, that's one of the challenges today is oftentimes those private circuits aren't encrypted. Now, some have options to do that. For instance, in Azure, we can leverage some encryption, but we tend to still be bound by that 1.25 gig limit. If we want to get above that, we have to do some creative things and run BGP and ECMP across multiple tunnels to try to get that bigger bandwidth. AVHX, you don't have to worry about any of that. We abstract all that complexity away and can give you the near line rate encryption both from on-prem to the cloud as well as within the cloud as well. Then in addition to that, we have the security services like the next-gen firewall insertion. So one of the nice things here is, obviously natively you could spin up a Palo Alto or a Checkpoint or any of these kinds of things. If we focus in specifically on Azure, what would be required is spinning up load balancers to provide HA for that. There would be some health checks that have to be configured. Oftentimes there's VRF that has to be configured within the firewall itself. Then in order to service chain that in line, there's UDR management, which is user-defined routes to redirect traffic to that firewall. And so as things scale, it can often become cumbersome. In addition to that, we have to make sure that we scale out appropriately to keep traffic symmetric. We may have to employ things like SNAT. And so it often becomes very cumbersome for customers as they look to leverage some layer 7 security features through next-gen firewalls. So through those partnerships that Faisal talked about previously, so Palo Alto, Checkpoint, and FortiGate today, we have API integrations with those firewall vendors. So what that means is that we can not only orchestrate the deployment of those firewalls, so we can deploy them within the VNets, go ahead and take care of any load balancers if we need to for scaling purposes, but then we will also automate the routing components of that. So we will service chain those in line, and we'll talk about how granular we can get with that. But what that means is because our controller, again, is multilingual, it can talk both Azure APIs, so we can update the UDRs and all the respective VNets that we need to. However, it can also talk to these next-gen firewalls, so we can update the routing tables within the firewalls themselves. Now, we're not going to touch the policies. We're going to leave that to you and your security teams. But the idea is, again, just to make a lot of this simpler. You define your intent in the controller, and we orchestrate all the complexity behind the scenes. Now, this is a key differentiator in my mind from Aviatrix to a lot of the other platforms that are out there. There are a lot of customers who will go out and say, you know what, well, I could just buy some CSRs and I can build all of this. Or maybe I have an SD-WAN solution and I can just build all this myself. To a certain extent, you're absolutely right. You could. However, the big gap there is, at the end of the day, you still have to connect the cloud underlay to whatever kind of overlay you build. And at scale, that becomes cumbersome. One of the nice things about the Aviatrix controller being native is that we can go ahead and speak to both. We can talk to the overlay, we can talk to the underlay. So what that means is whether we're using our transit and we need to orchestrate some UDRs to direct traffic there, or if we decide, okay, you know, well, I really like the Aviatrix transit, but for my VNets, I don't necessarily want to put a gateway in all of those VNets. I just want to leverage native VNet peering. The Aviatrix platform can still do that. So we can talk to Azure Native to leverage those cloud native services. So if an organization has a directive that they have to go Azure first, that's totally okay with us. We don't force customers down an overlay routes completely. We can live in both areas. We can orchestrate the native constructs where we need to, and then if we need to layer on those advanced services, using the same workflow, using the same GUI, using the same IAC, we can orchestrate the Aviatrix gateways to add those advanced services. We have some access components as well. I won't go into great details on these yet, but things like user VPNs that we have the ability to do some IPsec automation for large scale branch onboarding, things like that. We can also do some secure ingress and egress filtering as well. So this has been a big one, whether it's distributed or consolidated. So whether you have that from centralized in a hub or distributed, say you have a Windows Virtual Desktop deployment and you want to provide FQDN filtering as those desktop pools egress out to the internet, we can provide those services as well. And then one of the core tenets of the Aviatrix platform is the enterprise operation of visibility. Now, Faisal is going to show us a quick demo here later on of what this actually looks like so that you guys can see rather than just seeing it on a PowerPoint slide. But the key here is that one of the biggest challenges in clouds today is that so many cloud native things are just a black box. You know, you can't get that same level of enterprise visibility that we're used to in an on-prem world within the cloud. And so that is really the goal of Copilot, whether it's from dynamic topologies, whether it's from NetFlow, there's a myriad of things that Copilot can provide. But the idea is to be able to take a flashlight, start to shine that into your cloud or multi-cloud environment to help sort of in day two operations. Okay, so now what I really want to do really quickly is highlight a couple of use cases that are very, very Azure specific so that we can start to double click a little bit and you guys can see some of the advantages that Aviatrix platform brings and how it's helping customers in Azure specifically today. So I talked previously about UDRs. So again, those are user-defined routes. For those of you who aren't familiar with Azure, they essentially are static routes that you can define within your VNets and route tables and things like that to typically to insert third-party devices. For instance, like a next-gen firewall. Now, the challenge with those is one, they're static. So as things fail, as things change, we have to manually update those. And then over time, as things grow and scale, we have to manually make sure those are up to date, right? So as things start to scale out, what customers often run into is, you know, potential user error in case the UDR information was entered wrong, or just making sure that all the UDRs are in the correct places to keep sort of that network state. So at its core, what we refer to as route policy enforcement, but at its core, what that is just the intelligent orchestration of UDRs. So from our controller, because our controller has visibility into everything, we are able to orchestrate all of the UDRs within all of our VNets to make sure that everything is as we want it to be. Now, Where this really goes, though, is it's intelligent. The intelligent piece of this, I guess I should say, it really comes down to the controller's ability to understand the intent that the user is saying and then translate that into what it needs to do in Azure Native. So for instance, rather than just being limited to RFC 1918 space, if we were to have a spoke that was spun up that was in, say, the carrier grade NAT space, our controller is going to recognize that. And the controller is going to reach into all of the other respective VNets and plug in that CIDR range to provide communication based on how we want it. And we'll talk a little bit, about how granular we can get there. But if we want everything to communicate with everything, the controller would see this new VNet get spun up, reach into all of the other spokes, and program that UDR in. I mentioned this earlier from the firewall perspective, but in addition to that, let's say as a part of our overall state, we have a prod VNet that we say, okay, yes, we want everything to talk to everything. However, anything that's trying to talk to prod needs to go through this firewall. So what the controller can do is not, again, this is part of that intelligence, is be able to say, okay, I need to, in our spoke 50 here in the picture, I just need to push a UDR there, right? That says, okay, this is how you get to 164. But for my prod VNet, and in case my new spoke wants to talk to prod, I need to orchestrate the UDR so that it goes into the firewall, right? Now, our controller takes care of all of that for you. You don't have to worry about, well, what are the, how does that change my UDRs? What do I need to update there? The controller keeps that state for you. So in the end, essentially what it does is it keeps an end-to-end network correctness. So once you define what you want your environment to look like, the controller makes sure that that all stays accurate. Some additional things that we can do here is get away from some of the native limitations. So again, if you're familiar with Azure or tried to spin up hub and spoke environments before, there's obviously some limitations with the amount of native peerings. As you can see from this diagram, I have 2 spokes that are connected with Aviatrix. However, I have 1 spoke that's native, right? So again, we can facilitate that. However, with these native constructs comes native limitations. We can only have a certain amount of VNet peerings. In addition to that, if we had to change some of our VNet address space, we would have to drop our native peerings and re-peer. So using Aviatrix, those are some things that we can get past. We can dynamically update some of those VNet address spaces. We're not bound by the same number of VNet peers and things like that. Okay, so I talked a little bit about this, but this is a big use case for a lot of our customers, so I wanted to double click on it. It is encryption within the cloud. So I mentioned before, between our gateways, if you have our gateways deployed both in the hub and the spokes, we're encrypting by default, okay? However, if we need to do more than just that 1.25 gig, or in the case where we have redundant gateways, we run active mesh so we can do ECMP across some of those tunnels and get some higher rates. But if we have large amounts of data flows that need to be encrypted, we can also do that high performance encryption, or HPE. Now, again, that line rate encryption can exist within the cloud, so between 2 spokes across a couple of regions, as well as back to on-prem. So in the case of Azure, we're talking about our ExpressRoute circuits. When I say, again, near line rates, we're losing a little bit because of IPsec overhead, but on a 10 gig circuit, for instance, you're in the neighborhood of 9.85 to 9.9 gig. So we're losing a little bit, but not too much. Another key component on the encryption is FIPS compliancy. This is important to certain folks, but if it is something that's important to you, one key point to note is that none of the native Azure IPsec termination devices are FIPS compliant. So if that is something that's important to you, we are FIPS 140-2 compliant as well within our gateways. Okay, so another huge use case is something that we call FireNet. So essentially what that is the dynamic insertion, orchestration, and granular insertion of next-gen firewalls. So from our controller, we will again orchestrate the deployment of those firewalls. But then from a policy perspective, we will service chain those firewalls into the path where you want to see those. So based on the intent you define, we will orchestrate and update the UDRs, make sure all the routing stays symmetric, but that those firewalls stay in line on where you want them to be from an inspection perspective. Again, we don't touch the policies. We do have some integrations into, say, if you're running Palo Alto, we have some integrations in a Panorama, for instance, to where if you want to centrally, manage everything from your Panorama, we can push those updates to the Panorama directly rather than the PANs themselves, and have that be your central point of management. But that gets into more some architectural design conversations, but just know that we have the ability to do that. Another key feature is that we can do this either all in a single hub, or we can split these out. This is a common design practice that we see from a lot of customers, is they say, okay, I need a cluster for east-west traffic, and then I want a separate cluster for ingress-egress traffic, because my ingress-egress is going to have some heftier scaling requirements, right? It may have to do SSL offload. I may have to do packet level inspection. Whereas my east-west, that's really just RFC 1918 to RFC 1918, between spokes or between on-prem. And so I don't have the same level of requirements. And so I want to scale those independently. The Aviatrix platform can do both. We can consolidate that all into a single firewall stack, or we can support that dual FireNet. One of the nice things too is that we can scale out our firewall without the need to do things like SNAT, IPsec, or BGP like you would see in some other clouds. So our gateways become session aware, and so we don't necessarily need to worry about any of the SNAT functionality to keep traffic symmetric. So we can run active across all of our firewalls and start to scale that out. So you get really great performance. You don't have to worry about any kind of active passive type scenario where you're just sort of letting a firewall sit there until you actually need it, so you're not wasting compute dollars. And then from the controller, again, we'll define what those security policies are, and service chain those firewalls in the path on where you need them. Now, let's again, I mentioned we would dive into this a little bit. So what does that mean when we say we're going to service chain those in the path, right? Historically, within Azure, the way that we would do this is we would sort of, define our VNets and say, okay, well, we have some blue VNets, we have, a couple red VNets, and then maybe a shared services. So blue can't talk to red, red can't talk to blue, but they can both talk to green. And we would have to manufacture the UDRs to push everything to the firewall, and then through our firewall policies, manually create the right LAN to LAN policies that would enforce that behavior. And then anytime anything changed or dev grew, or there was a new test VNet or a couple new prod VNets, or even a new region, we would have to go back and review all this and make sure that everything stays straight. One of the nice Aviatrix is we have this concept called global security domains. And so essentially what we do is we say, okay, let's forget about the topology for a second, and let's just start to color code these directly, right? So we don't care where they're at. This VNet could be in region 1 or could be in region 2, but we're going to define these as a security domain. So these are going to color code blue, these we're going to color code red, and these we're going to color code green. And then we're going to define our intent based on the controller that says, okay, we want blue to be able to talk to green, red can be able to talk to green, but they can't talk to each other, right? So that's essentially the concept of security domain. So what we do is we logically group like VNets from a security posture together, and then build a policy based on those groupings. And our gateways become domain aware, so they're able to determine, okay, I'm either going to allow this traffic, I'm going to deny this traffic, or I need to push it to a firewall for inspection. Now, the nice thing about this is we can also extend this across clouds. So within that blue security domain, that could include VNets in US East and US West, but could also include a VPC in AWS or a VCN in Oracle, right? And that starts to become really, really powerful because it starts to simplify your overall security posture. You just sort of define your intent, and the Aviatrix platform takes care of all of that complexity. All right, so one more real use case that I want to dive in real quick is on really sort of an architectural flexibility. Typically in Azure, one of the probably 95 to 98% of customers today in the IaaS world are deployed in a hub and spoke environment, and that tends to be the way that things scale well, right? And it makes things like transitive communication a little bit easier, right? Now, the challenge is the hub and spoke is a two-tiered system. We have a hub, and then our business units or our applications or our environments are all spokes off of that hub. What we get from a lot of customers is they need another level of segmentation, almost a third tier. And so with the Aviatrix platform, combining a lot of our services, we can start to provide that. So this is just some this is an architecture we did for another customer. But just to illustrate some of the design flexibility that you have, is we can start to create more of a three-tiered system. So we can create a centralized hub, which has control to back to on-prem, as well as shared services. And then we can start to carve out different environments. Now, these environments could be, again, based on an environment or a business unit or an application, what. But these become isolated little pods. And within these pods, we can have our dedicated hub and spoke, so they can have their own little sandbox. They could have their dedicated FireNet for internet access or partner connectivity. But this becomes completely autonomous. They can use their own IP address space. They're isolated to their own fault domain, and they all are just independent and live by themselves. Now, they all have access back to on-prem. They all have access into shared services. One of the other services that our gateways provide is things like NAT capability. So if we do have overlapping IP space, or we need to potentially tie two environments together, we can start to tie them together at the hub, take care of any kind of natting that we need to do potentially here, and facilitate that communication.